Hi class, welcome to the makeup recording for week 1 lecture 2. So I hope you are watching this recording before the start of tutorial 1. And if you are watching this recording, I hope you could physically attend the lectures because I'm trying to make the lecture content interactive. So I will ask you questions during the lectures, and you can also provide me feedbacks during the lectures. So please try to attend the lectures physically. And now we can start. So this is today's outline. So first we will go through some updates for this course, and then we will discuss the entity relationship modeling of which is a semi-formal data modeling technique. And then we will go through the relational modeling technique. So first, the first update is we have some new course materials online now, and all the tutorials are on WebCMS now. And second, when I was preparing these lecture slides, I found some treasure, which are previous lecture notes. They have much more details than these slides. I think it's because previously UNSW was running 12-week semesters, but now we only have 9-week terms, so that's why it has more content. However, not all the content inside these course notes are examinable, and only what's covered in the lectures and slides and tutorials are examinable. And these course notes could be quite old because I found this slide. So can you do a quick math to calculate how old are the slides? Actually, the slides are about 20 years old. So since they are quite old, so there could be some differences between these course notes and the slides. So that's the first update. So now we have these three types of materials, course materials. We have the lecture slides, we have the previous course notes, and we have the textbooks. And some students were asking me about the textbooks, and I think normally you don't need to read it. You don't need to read them because textbooks are really they provide a lot of details, and it's more like a dictionary. So whenever you encounter some ambiguous concept or there are some knowledge you're not sure, you need to check the ground truth. You need to find out the exact meaning or the exact concept. Then you can go and look into the textbooks. Normally the course notes and lecture slides should be enough. So how do you handle these materials? If you say, I just want to pass this course, then the lecture slides plus the tutorials should be enough for you. And however, if you say, okay, I want to be the master of database, then I suggest you to look into the course notes and textbooks. And talking about passing this course, there's an important thing you will need to notice. It was not reflected in the course outline. I think it's now updated there. So there is an exam hurdle. So you will need to score 40%, at least 40% in the final exam, and have a 50% overall score to pass this course. So this is something you have to keep in mind. So the last update is related to those who are attending this lecture. So please try to keep quiet during the lecture. So because since you are watching the recording, you can do whatever you want. So let's skip this really fast. And now we come to the main content of this course, that is the entity relationship modeling. So let's have a quick recap of the process of data modeling, because it is a special, it is a concrete case for data modeling. So there are three aims for data modeling. We need to cover the information in the database. We need to cover the relationships between the different data items in the database. And we need to cover the constraints on the data when we do data modeling. So these are the three aims of data modeling. And remember, data modeling is a design process. So there's no absolute right or wrong. As far as your design makes sense, it's okay. So, and the input of the data modeling process are the requirements provided by the users normally. And the output is the semi-formal description of the database structure. And ER models is one of the formal descriptions here. So let's first go through some concepts and definitions of entity relationship modeling. So remember, the data modeling is like a way of describing or modeling the world. And ER modeling provides models the world as a collection of interrelated entities. And ER models have three major components. The first one is attribute. You can think of, this is actually ER model has a lot of connections with. It is very similar to, a lot of concepts here are very similar to object-oriented design. So attributes are more like the variables of objects. So an object could have some attributes. And entities are collections of attributes and belonging to an object. So you can think of entities as objects. And relationship is just the association between entities. And ER model is not a standard, so there could be some variations when we try to really implement the ER model. So there could be variations, and the lecture notes use the notations from these two textbooks for the sake of simplicity. And when we want to visualize ER models, we normally use ER diagrams. And an ER diagram consists of a collection of the entity site definitions, a collection of the relationship site definitions, and the attributes associated with both entities and relations, and the connections between the entities and relations. So here I would like to say that, okay, we sometimes we don't just say entity site, and that's too long for terminology here. So sometimes we refer entity as entity site. So please take note. This is an example ER diagram. It is you can see a lot of symbols here, but don't worry, we will go through all the symbols here one by one. So these are the typical symbols used in ER diagrams. You may notice I have crossed out two symbols here. It's not because they are not examinable. It's because they seldom appear in the following up slides. So we will cover the rest of the symbols one by one with examples. And I will come back to this slide and describe the meaning of these two symbols. So first, let's go through the key concept in entity relationship modeling. So the first and the most important concept here is entity set. So an entity set could be viewed as either a set of entities with the same set of attributes, or you can logically think of it as an abstraction of a class of entities. So it's more like a class in object-oriented design. And another key concept here is called key or superkey. Is a set of attributes that could be used as a unique identifier of an entity. So naturally, there are some attributes that could be used as a key. For example, if we want to identify a person, what can we use as a key? We can use name, the name attribute, plus the address attribute, plus birthday as the attribute here, as the key here. So, or we can use, sometimes we can use a single attribute as a key. For example, we can use the social security number as a unique identifier for a person. And the concept of candidate key is a minimal key, is a minimal superkey. So a candidate, because keys are sets of attributes. So let's think about an extreme case. We can use all the attributes of an entity as a key, right? It could definitely uniquely identify that entity. However, not all attributes are needed. So it is not a candidate key. All the attributes, the set of all attributes is not a candidate key because not every one of them is needed to uniquely identify an entity. So the minimal set of attributes that is required to uniquely identify an entity is called a candidate key. So this is the definition of candidate key. And for primary key, it's quite straightforward. It's just the candidate key chosen by the DB designer. So it's just a candidate key. And keys in ER diagrams are represented by underlining. So let's see an example here. So we can see this is an ER diagram for a bank database. And we have for the branch of a bank, we can use the name plus address as the unique identifier for this branch. Remember, when you do a bank transfer, when you are asked for the recipient details, you will need to key in some branch information, right? So you will need to key in the name and address of the bank of that branch. So this is actually these two attributes could actually be used as a key for a branch. So this is the key here, and you can see for the customer account, we can simply use account number here as the key. As for customer, normally for people, we don't use name as the unique identifier because a lot of people have the same name. Not for this person. If you have attended our last lecture or if you have watched our last recording, you are familiar with this guy. And I don't think he has there's someone else with the same name as him, but for most of us, there are someone in the world have exactly the same name as us. So we can, for people, normally we don't simply use names as keys, but instead we could use the customer number as the primary key here. And now let's do a quick exercise. So can you identify some candidate keys for a student here? For the student here, you can pause the video and think about it, and I will show you the answers. So there are some single attribute keys we could use. For example, it's very straightforward. We can just use the student ID as the unique identifier. And we can also use phone, assume everyone just provide one phone number here. And same for email. And we could also use name plus address plus date of birth as a candidate key here, as a key here. So that's about the exercise. And here are more concepts. So the second most important concept for entity relationship modeling is relationship. So relationship is just an association among several entities. And for example, we can say customer is the owner of account. So is owner of here is the relationship. And relationship side is just a collection of relationships of the same type. And there are three properties associated with relationships. The first property is called degree. It is used to describe the number of entities involved in the relationship. There could be more than two. And the second property here is cardinality. It is the number of associated entities on each side of the relationship. So there could be one-to-one, there could be one-to-many, there could be many-to-many. So this is cardinality. And the third property here is participation. It is used to describe whether every entity must be involved in this relationship. So these concepts seems to be quite overwhelming, right? So let's go through the examples to see the details. And before we jump into the examples, some of you may have, if you search about relationships, if you search about ER diagrams, you may see some different notations. And these notations, don't be surprised because remember what we have discussed just now, ER modeling is not a standard. There could be alternatives. There could be variations. So these are some alternative notations which are also quite popular, but we won't be using them here. And let's go through some examples here. So the first property we are going to cover is degree. So degree is just the number of entities related or connected by a relation. So it's quite easy to and straightforward here. So for this relation here, there are two entities. So the degree is 2. For this one here, there are 4 entities. So the degree is 4. And the second one is cardinality. It is used to describe the number of entities on each side of the relationship. There could be one, there could be many. And can you see some patterns here? And what kind of notation is used to describe one? What kind of notation is used to describe many? And with arrow or without arrow? So you can think about it. You can pause the video and think about it, and I'll tell you the answer now. So with arrow, it means one. Without arrow, it means many. So we can look into this one, the branch and account example here. So one branch can hold many accounts. So the relation, the line here with arrow means 1 because one branch is used here, is involved in this relationship here. And you see the line without an arrow means many because many accounts could be held by one branch. So this is how you remember this cardinality representation or notation. And the last property here is participation. It is used to describe whether every entity is involved in this relationship. So can you see the pattern here? Whether the seek line is used to describe a complete participation, which means all the entities or every entity should be participating in this relationship, or the thin line is used to describe this complete participation. So you can pause the video and think about it, and I will tell you the answer. So the thick line is used to describe total or complete participation, which means every entity is involved in this relation. And the thin line or the normal line is used to describe partial participation, which means an entity may involve in this relationship and it may not be involved in this relationship. So for example, for the first relationship, what we can do is, this is how we can describe the relationship. We can say, remember, with arrow means one, without arrow means many. So we can say a lecturer may teach, because this is a thin line, we should say may teach one course, because there's an arrow, so we should say one course. So a lecturer may teach one course. And if we go the other way around, we could say every course, because this is a thick line. We need to say every course. Every course is taught by one or more lecturers, because there's no arrow here, so there are multiple lecturers involved in this relationship, so it's one or more lecturers. So you could associate thick and thin lines with some keywords. Whenever you see a thick line, you will just think about, okay, every entity is involved. And whenever you encounter a thin line or normal line, you just say may, and they may be involved in this relationship. So this is participation. And another thing here to notice is sometimes we have to put relationships can have attributes, and sometimes we have to put some attributes under relationship. For example, products could be sold in shops, and the price of the product is an attribute. And where should we put this attribute? Can we put it under the product? Actually, no, because the same product could have different prices in different shops. So we can't actually put the price, we can't actually associate the attribute of price to product. And of course, we cannot associate it with shop. So instead of putting this attribute under any of the entities here, we can put it under the relationship of sold in. So it makes a lot more sense. So this is all about relationships. And another key concept here is weak entity set. Weak entities are the entities that exist only because of the association or the existence of other entities. It relies on the existence of other entities. So for example, let's assume we have a database of a company, and the employees are some entities that we must have in this database. And the family members of employees are actually weak entities, because if the employee no longer works for this company, then it's meaningless to keep the record of their family members, right? So the family members of the employees here are weak entities. So weak entities, they don't have a primary key, and we don't need a primary key to uniquely identify them. Instead, we use discriminators, and the definition of discriminator is similar to keys. It's a set of attributes. And weak entities will always need to be considered in conjunction with the associated strong or normal entities. So although the weak entities, they don't have a primary key, and they have discriminators, and we can use the discriminator of a weak entity plus the primary key of the associated strong entity as the unique identifier of a weak entity. So, for example, there are two teams here in this scenario. However, if we associate a team with a strong entity, which is his father, the father of team, then we could uniquely identify team. So weak entities could be uniquely identified with the discriminator plus the primary key of the associated strong entity. So let's see some notations and examples here. So in ER diagrams, weak entities are denoted by double boxes, and the strong or weak entity relationships are denoted by double diamonds, and discriminators are denoted by dotted underline. So in this example here, an employee could have some contacts. And let's try to describe this relationship first. So you see the arrow, whenever you see arrow, there's one. Whenever you see there's no arrow, there's many. And this is a normal line. This is a thin line. So it means it's partial participation. And this is a thick line. It means complete participation. It means array. So in this, if we go from left to right, we would say an employee may be related to one or more contacts. So this is how we describe this relation from left to right. And if we describe it reversely, we will say a contact must, or every contact is related to an employee. So this is how we describe this relationship here. And since contact is a weak entity, we could use the discriminator name plus of the contact, name of the contact plus the associated employee, the social security number of the associated employee. So this is about how we denote weak entities. And similar to object-oriented design, ER modeling could have subclasses and inheritance. So it is like an extension to the standard ER model. So to empower it to capture more mechanisms of the real world. So a subclass of entity set A is a set of entities with all attributes of A plus its own attributes, and it is involved in all of A's relationships plus its own relationships. So in short, the subclass inherits the attributes and relationships of the parent class and has its own attributes and relationships. So this is so the concept is very similar to the inheritance concept in O design. So here are more concepts. Today we will cover a lot of concepts and definitions. So if an entity has multiple subclasses, they could be disjoint, which means the relationship between the subclasses is exclusive. So its entity can only belong to at most one subclass. There could be overlapping. So it means an entity might be belonging to several subclasses at the same time. And there's another property. So it's about completeness. It's similar to the concept of participation. So it's like if it is total participation here, it means all the entities of a parent class must be belonging to at least one subclass. So this is total completeness. And partial means some entities may belong to no subclasses. So here are some examples. So there's a special case we need to notice here, that is a. So if a parent class has only one subclass, then we can use is a here. So for example, a manager is an employee. So use is a here, and an employee is a person. So there's only one subclass, so we can simply use is a here, and it is denoted as a triangle with the letter ISA inside. And as for if there are more than two subclasses, we just use a circle with the letter D or O inside of the circle. So for example, for D represents disjoint and O represents overlapping. So let's go through this example here. Employee could be permanent or contract or on contract, and it cannot be both a permanent position or contractor. So this is why it is a disjoint. So it's exclusive. Employee cannot be both permanent and on a contract. So this is why we use letter D here. And in this example here, there's overlapping. It means a person could be both a doctor and a patient at the same time, because sometimes doctors may get sick. So that's the meaning of the disjoint and overlapping here. And as for completeness, for total completeness, we use the double or thick line. And for partial completeness, we just use a normal line. And for this example here, for the employee example here, we could see that it is a thick line. It means an employee must be either a permanent or on contract. So this is total completeness. As for this example here, it is partial completeness. It means a person could be neither a doctor nor a patient. So this is the meaning here of completeness. And sometimes, just now we have go through some examples, which are some simple ER diagrams. However, in real life, the ER diagrams could be very, very large. And a common way of handling large ER diagrams is that we could define the entity size separately, showing the attributes associated with the entities. And then we combine the entities and relationships on a single diagram, but without showing the entity attributes. You can still put the attributes of the relationships there, and you can see in this example here, we can put all the entity and attribute details here, and we can put the relationship details on the other side. However, if it is still very large, we may consider using several linked diagrams to represent the entire system. So let's do a quick exercise here to go through all the concepts we have learned just now. So let's try to describe some of the entities, attributes, or relationships here in this ER diagram. So first, let's go through this person here. So can you think of what are the attributes of the person entity, and what is the key here, the primary key used here? So you can think about it. You can pause the video and think about it, and I will tell the answer. So the social social security number is the primary key of the person. So because you can remember, underlines are used to denote primary keys. And the second practice is, can you describe this inheritance here? So you can pause the video and I will tell you the answer. So first, this is, you can see there's a letter O here inside this circle. It means overlapping. It means a person could be both a medical professional and a patient at the same time. And you may notice there's a thick line here. So in this weird world described by this ER diagram, a person must be either a medical professional or a patient, or maybe both. It cannot. It has this person has no other choice. So this is weird, but it is how it is. So let's go through the third example here. So can you try to describe this inheritance? You can pause the video and I will tell you the answer. So you can see there's a letter D here. It means disjoint. It means the relationship is exclusive. So a medical professional must be either a doctor or a pharmacist, and cannot be both a doctor and a pharmacist. And since this is a thick line here, so it means it's a complete participation. So a medical professional has to be a doctor or a pharmacist. So there's no other choices. So let's go through the first example here. Can you try to describe the relationship from the doctor to prescription? So you can pause the video and think about it, and I will tell you the answer. So first, let's look for arrows. There's no arrows in this relationship, so it means it's a many-to-many notation. So it means if we want to describe from doctor to prescription, we can say, and the second thing we need to notice here, the second thing we need to notice here is the thickness of the line. So this is a normal line, this is a thick line. The normal line means partial participation, and thick line means total participation. Since here is a partial participation for the doctor, we just use the keyword may. So it means not every doctor is involved in this relationship. So what we can say is a doctor may make one or more prescriptions. A doctor may make one or more prescriptions. This is the answer. And can you think about how can we describe from the prescriptions to doctor? How can we describe this relationship the other way around? You can pause the video and I will tell you the answer. To think about this, and I will tell you the answer. And the answer here is, here there's no arrow at all. It's many-to-many, and because this is a thick line, it means every prescription is involved in this process, in this relationship. So it means what we can say is every prescription is made by one or more doctors, and that's the answer here. And the fifth example here is just to show you that sometimes relationships could have attributes, and sometimes we must put attributes under relationships. Inside this exercise, you may notice, okay, there's a symbol that we haven't encountered before. That is the dotted line, the circles with dotted line. It means, if we go back to the previous slide, If we go back to the previous symbol table here, we can see that it means derived attribute. And there's another thing here, there's double line. If you use double line, it means multi-valued attribute. I will give you an example of each one of them. So multi-valued attribute means the attribute contains multiple values of the same type. For example, in some systems, a user could provide multiple email addresses, and in that case, as backups. So in that case, the email address attribute is a multi-valued attribute because it's a list of email addresses, it's a set of email addresses. So that's why it's a multi-valued attribute. And as for derived attribute, we can just use the example here in our exercise. And we can just use the example in the exercise here. You can see age is a derived attribute. Age is a derived attribute. It's because it could be derived, as the name indicates, it could be derived from other attributes. For example, here in this example, we have the date of birth of a patient, and we can actually easily calculate the age of the patient with our current date. So age here is a derived attribute. So that's all about the concepts of ER models. And you can see that, okay, ER model is very powerful. It can describe a lot of mechanisms of the real world. However, there are some limitations of ER models, and most of them are related to constraints. So the first limitation is we cannot define attribute domains. We cannot define the set of valid data, values for attributes with ER diagram. And the second thing is the second limitation here is ER models cannot capture computational dependencies. So it cannot calculate these kind of dependencies. And there are many more general constraints that ER models cannot capture, cannot describe. However, some of these can be handled later in the relational model we will discuss today. So before we jump into the details of the relational model, let's have an overview of all the data models which will be covered in this course. So the first one is entity relationship model. It's a natural way of this. It's very natural, and it's easy to use because it's very similar to object-oriented design, and but it is not that formal. And the second model here is relational model. It is quite formal, and it is also very, very powerful. However, it's not as explicit or not as straightforward as ER models, which we will see later. And we will also learn SQL schemas, which is very close to relational model, and we will be using them a lot once we learn SQLs. And there are many other types of data models, but we will not cover them in this course. So now let's come to our last topic today, which is relational modeling. So remember, data models are used to describe or model the world. So for relational model, the world is described as a collection of interrelated relations or tables. So relations are, you can think of them as tables. And the goal of relational model is to provide a simple and general data modeling formalism. So we could apply some formal analysis techniques to to these relational models. So here are some backgrounds of relational model. So it has existed for over 50 years. It was first proposed by Code in 1970, and the inventor of this concept has won a Turing Award, and because the impact of relational model is very huge. And talking about Turing, you may have heard about him. He's one of the greatest computer scientists in history, and you may have heard about some concepts like Turing machine, like Turing completeness, or maybe Turing test. And you may also know that the logo of Apple, the company, the Apple company, is related to a story of Turing. So you can search about it if you're interested. And let's come back to the concepts here. So here are some more concepts and definitions for relational model. So the relational model describes the world as a collection of interconnected relations or tables, and there's only one structuring mechanism used in relational modeling, and that is relations. And relations are used to model both entities and relationships. It's like we put everything inside different tables. So each relation or each table has a name. You can think it as a table name. And each relation has a set of attributes, which is like the column headings or the table header. And for each attribute, it has a name which is unique inside the table, inside the relation. And it has an associated domain, which is defined as the set of allowed values, which is used as a constraint. And here are more terminologies. So for a relational schema, it is like a combination of the relation name and a list of attributes. So and each attribute has an attribute name and the domain. And the tuple here is a list of values. It is you can think of it as a table row. So a tuple is equivalent to a row of the table. And an instance of a relation is a set of tuples. It's a set of rows. So you can think of it as an instance of a table, just a concrete table. So please note that for tuples, it's a list, it's a vector. So ordering matters here for tuples. However, for relation, it's a set of tuples, it's a set of rows. So ordering doesn't matter here. So that's the key thing to notice here. And domains are comprised of atomic values. So there's no composite or multi-valued attributes. So for example, the domain cannot be a list of integers, a list of strings. It cannot. Or it cannot be a struct or an object. So domains should be atomic. And the second thing to notice here is there's a special value, which is null. And it is quite common in most of the programming languages, which means nothing there. So null belongs to all domains. Null belongs to all domains. And another key thing to notice here is that each relation should have a key. And this key, the definition of key here is similar to the definition of key in ER modeling. It's just a set of attributes which is used as the unique identifier of a row, of a table row. So this is the definition of key. And as for database, it's just a collection of all the relations or tables. Let's see an example here. This is a relation. So this relation we have omitted the domain here. We have omitted the constraints here for simplicity. So this relation is called account, and it has 3 attributes. And account number is a key here, and it has branch name, it has account number, it has the attribute of balance. And an instance of this relation is here, it's shown here. If you are careful enough, you may notice that we are using a curly bracket here. It means this is a set. So a relation is a set of tuples, a set of table rows. So ordering doesn't matter here. Ordering doesn't matter here. However, if you see, if you look into each row or each tuple, you can see we are using some parentheses here. So it means it's a vector, it's a list. So ordering matters for tuples or rows, for the attributes, for the values inside the row, the ordering matters. So this is the example. We can easily convert it into a table here. So this is essentially the same as what we have seen in the previous slide. So we have the table, we have the relation, we have the attributes of the relation, and which are the column headings or fields of the table. And the tuples of the table, the tuples of the relation are the rows of the table or the records in the table. So this is the example of a relation model. And let's have another example, a more complicated example here for database. For multiple tables. So consider this ER data model for a bank. What kind of tables could we have? So it's quite straightforward to convert entities into tables because each entity can naturally become a table. For example, you can build a table called branch, and you can have 3 attributes: branch name, address, and assets. For customer, we can do the same thing. And remember, in relational modeling, relations are also used to capture relationships in ER modeling. So we could have tables for relationships as well. And here's an example. Besides the entities like account, branch, and customer, we can also have a table for the relationship of held by. We can have this table could contain an account, and that is held by a customer. So this is the example here. However, you may notice there should be some constraints to ensure to make sure that the content of the data of the database is clean or is genuine, because you see the account, we should somehow to make sure that the account number here is a valid account number inside the account table. And how can we make sure this happens? So there are some constraints in relational model. So in order to represent the real world problems, we need to describe what values are allowed or are not allowed in this for this attribute, and we need to describe what kind of combinations of values are not allowed in our system. So we have constraints, and there are 4 basic types of constraints. The first type is domain constraint, which is used to limit the set of values that attributes can take. And the second type of constraint is the key constraint. It is to make sure that there is a key for each table that could be used to uniquely identify rows. This is the key constraint. And the third one is entity integrity constraint, which means that which is to ensure the integrity of keys, because keys could be consisting of several attributes, and we need to make sure that all the attributes involved used as a key is valid. And the last constraint here is referential integrity constraint. It is used to make sure that the references to other tables is valid. So let's go through them one by one. So for domain constraints, we could have, for example, we could have employee age. Let's consider the example of employee age attribute. So normally we can assign it, we can define it as an integer, and this is the constraint from the data type point of view. As for the value, we can also add some constraints for the value of this attribute. So we can say that the range, the age of an employee should be in the range of 15 to 66. So this is the domain constraint. And there's a special case. Remember, there's a special type of value for attributes. So that is now. Now could satisfy all domain constraints except for not now. Except for not now. So now is integer. Now is a string. So now is a special case. And for key constraints, there are some. And this is to make sure that there is a key for every table that could be used as a unique identifier. So this is the key constraint. As for entity integrity constraint, it is used to make sure that the key is valid. For example, we can for the class table or relation, we can use the date plus time plus location as the key for uniquely identifying a class. So if an attribute here is null, then it means the key is not really a valid key. So it's not, it violates entity integrity here. As for referential integrity, it is used to describe the references between tables or relationships, and it is related to the notion of foreign key. So you will encounter the concept of foreign key a lot when you learn SQL. So just now we have discussed, okay, the account. We have to make sure that the account number is a valid account number that exists in the table of account. And we also need to make sure that the customer in this held by here should be a valid customer inside this customer table. So how can we make sure this happens? So we use the concept of foreign key, which means that from the name of it, we will know that, okay, a foreign key is actually borrowed from another table, and it is a primary key of another table that appears in this table. So we can use foreign keys to connect things up, and this figure here shows you the connections we can make for the example. So let's have some formal definition for foreign keys or referential constraint. So a set of attributes in relation R1 is a foreign key of R2 for R2 if there are two cases. If there's a single attribute, if it is a single attribute key. So if the attributes in F correspond to the primary key of R2. So then it is called a foreign key in R1. So this is the first type of the first scenario. The second scenario here is the value for f in each tuple of R1 is either a primary key in R2 or is entirely null. So this is a special case, and it is also a type of we can also consider this case as a foreign key. And foreign keys are critical in relational databases because they could be used as the glue that connects or links individual tables. And it is a way to assemble query answers from multiple tables, because sometimes we don't just look up for the information inside just one table. We need to combine multiple tables together and look for the information and do the query. So we use foreign keys to connect tables. And it is a relational representation of the ER relationships. So that's why foreign key is very, very important. And let's have a quick recap of all the concepts we have covered in the relational model. The first is attribute. Attribute is just like a domain. It's like a data item with a name and a domain, and it is like a column inside a table. So attributes are columns, and tuples are list of values. It is like row. It is like a row in the table. So attribute, column title, tuples, rows, and relation instance is just a set of tuples, and it is like an instance of a table. And we have multiple different types of constraints. Basically, we have 4 types of constraints. We have the domain constraint, we have the key constraint, we have the entity integrity constraint, and we have the referential constraints. So these are some key concepts we have covered for the relational model. And if we compare entity relational model and relational models, we can see there's a lot of correspondence. So relational attributes actually correspond to ER attributes, although ER attributes, they don't have domains. So the difference here is relational attributes, they have domains, they have the domain constraint. And relational tuples correspond to ER entities, and relations correspond to the set of ER entities. It's a collection, it's a set of tuples, therefore it's a set of entities. And relations can also correspond to ER relationships. So we can put relationships into tables. And there's some more formal mapping of ER model to relational model, and we will cover that in the next lecture. And that's all for today's lecture. And this should be get you prepared for tutorial 1. So thank you for watching this recording.